Hello, this is Allison Hunt, and today I'll be solving a Fourier transfer problem. So we're asked to find h of t and y of t. And we have h of omega to begin with, so we can get h of t from there by just going straight back out from our Fourier transfer domain. But first we're going to write it out like this. H of omega equals 1 over 1 plus j omega e to the j omega, which is just pulling out that 2 over 2 that's already in our h of omega function. So then we can go straight back into our time domain using our inverse Fourier functions, where we have h of t is going to be equal to e to the negative t plus 1 times u of t plus 1. And this just comes from 1 over 1 plus j omega equals e to the negative t. And then e to the j omega is the same as e to the 1 j omega, which provides our time shifting. So from there, we can go on to find y of t after this. And y of t is equal to h of t convoluted with g of t. Or y of omega equals h of omega times g of omega, which is much simpler. Okay, so first we need to find g of omega because we don't know that currently. So g of omega is going to be equal to pi times the delta of omega plus 1 plus pi times the delta of omega minus 1. And that's just one of our Fourier transform formulas for what the cosine of t is. So from that, we now have that y of omega is going to be equal to pi times h at omega times the delta of omega plus 1 plus pi times h at omega times the delta of omega minus 1. And from that, we can evaluate, since this is a delta function, we can evaluate h of omega at each spot where the delta function would be, because they're not going to exist anywhere else. So we're going to have pi of h minus 1 times the delta of omega plus 1 plus pi of h of 1 times the delta of omega minus 1. And from there, we can go into that, and our h at minus 1 is going to just be equal to 1 over 1 minus j, e to the j, or e to the negative j, times the delta of omega plus 1, plus pi times 1 over 1 plus j, e to the j, times the delta of omega minus 1. And from this, we can get that y of t is equal to 1/2 1 over 1 minus j e to the negative j times e to the negative jt plus 1/2 1 over 1 plus j e to the j times e to the jt. And if you're wondering where that 1/2 came from, it's because the Fourier transform of e to the negative jt is equal to 2 pi times the delta of omega plus 1. So we divide the 2 pi over to the other side, the pi's cancel out, and we get 1 over 1/2. And that is your final answer. Thank you for watching.